Hello everyone, good evening. I welcome you all for day two of our project session, second project. And This project is retail project. Day one was went in so much discussion related to the data set because obviously domain knowledge is required to understand what is present in the data, what every feature means, what kind of value it possesses. Then only we can be successful in drawing the, unless and until we don't know what is present in the data, so it is difficult for us to analyze and to get the results. Okay, fine. So, in our data set, we were having the terms like wholesale, retail, revenue generated, and that's what I told they are related to revenue. By seeing the features, the entries present in the features, we do have discrete values also. We do have your continuous values also present in the features, and for that reason we decided whether it should be a revenue, whether it should be a number of items cannot be in fraction, but you are having fractional values also, so whether it should be a revenue, what it should be. Okay, so a lot of discussion happened. And here I want to again describe the things related to the data, is what I did the analysis accordingly. The wholesale, you are having a feature that is wholesale, and a wholesale is a person or a company who sell the products. Ultimately, the retail is selling of products to the consumer. Now there are different modes. So wholesale is also one of the mode. Okay, who sell the products to various outlets to various retailers, and then later on retailers sell to the customers or the consumer. Okay, that's what they do. Okay, so there can be like either a middleman, or there could be like direct selling also in wholesale. It's not mandatory. There is always time middle. There could be direct also, indirect also. Then, in case of retail, the retail is again a person or a company who sells the products directly to the customer. Okay, so and obviously for a profit. See, everyone is going to work for a profit. Here also we are having a profit. Okay, but for a lower price, not that much, because we are actually selling the items in bulk. The wholesale, they do sell the items on bulk. However, the retailers, it depends how many consumers are going to purchase the items from them. So their goal, their idea is to gain the profit. And revenue generated is, it refers to the total income earned by a business from its sales or the goods or the services. Okay. So for a specific period of time, we do have in our data set, we are having a year and the month. And what we have discussed in the previous session is, year is 2020, only 1 year we are available with. And in months, we are having 1, 3, 7, and 9. That means we are taking quarterly analysis, and quarterly we are taking the first month of the quarter. Only how many sales occurred for a particular supplier, what item ID, what item sold, its revenue generated, its wholesale, and its retail sale is available with us in the data. That's what we are available in the data, nothing else. We are not available with how many items sold, what is the price of the item. Just we are having the item name, item ID, supplier, and we are having item description also. Quantity we don't have in the data, price we don't have in the data, and we can't also assume from our side. Okay, that's the issue. So revenue generated can be like, how you are going to calculate. See, there are many ways to calculate the revenue generation. Okay, so it helps the business to make informed decisions. It can be like inventory transfer. That means movement of goods from one store to another store. That's what I told. Movement. That is inventory or revenue transfer means moving the goods from one to another. That is what it can be like a payment mode also. That means a retail transfer can also refer to a payment. Okay, that means any of the service, payment service, if you are using either credit card or whatever. Okay, it can be like retail remittance. So transfer, we are saying revenue transfer, and it can be in any mode. So if you're pushing the goods from one place to another, then also revenue will be generated. If you are taking the money on the basis of the selling of the products, then also money will be generated. Money will be there, revenue will be generated. So let me share my entire screen and again refer to the data set. Okay, now I'm sharing my entire screen and see the data set. So the data set is this. You are having year, month, supplier name, item code, item description. This is what the item description is. Okay, then item type, retail sales again. Just do refer it in form of revenue. Okay, that means if I would say for the year 2020, for the month 1, this is the item, this is the type of the item, that is wine. There is no revenue for it for the supplier for a month of first for this particular item. There is no revenue generated for it. However, there is 2 units of revenue generated for this particular item. Okay, for the supplier. That's what we can say. We haven't done the transfer of revenue in this particular case. Okay, there is no revenue transfers. And that will be again in, I think it will again in a form of a payment mode. That's what the data means. Okay, so these three terms were very much like so much we invested our time in discussing what actually they mean. And we are having negative values also. That means it may be showing a loss. Some people said, sir, it may be an outlier also. In every column, I am having some negative values. So who is going to do such kind of mistakes in every column like this? They are having negative. Okay, might be the person in a loss, supplier in a loss, nothing obtained in this particular month for a particular product. I got this product, but there is nothing to sell. Ultimately I sold it in a loss. Something like that can be possible. Many things. Okay, so yesterday only we did started with the building project also. We started with the code also. Okay, and here is the code. Fine, let me make it enlarged. Okay, fine, here it is. So we started analyzing the data. I took the basic libraries and read my data, printed head and the tail, shape, everything I did. Okay, fine. Yes, Madhumita, ask the question.
Sir, I have one small question here. So, what would be the units of this particular columns? I
What will
can
be the
see
unit of revenue? What do you think?
revenue is currency,
Ah,
correct?
currency. Yeah.
So now revenue sales is currency,
Hmm.
and revenue transfer,
Hmm.
would it be the count or is it also the currency?
See, if I say payment transfer, so what it would be? Payment transfer, what it would be? Because revenue transfer or retail transfer,
Number of transactions.
number of transactions. Okay, so
So it's a
number of
count.
transactions can be fraction. That is one of the question to me. That's one of the question. This is
Hmm.
the question I'm
Yeah.
asking. Can it be negative? Can it be in a fraction? If I would say number of transactions can be in a fraction. Because if we let you know to see the data, this is retail transfers 11.84. What does it mean now?
Correct.
तो नंबर
So
तो नहीं होना
mostly
चाहिए,
it
ट्रांसफर
should
तो
be
नहीं
the
होना चाहिए.
currency, right?
हाँ, इट विल बी
Yeah.
करेंसी ओनली. और मुझे लग रहा है ये पेमेंट कराया आपने.
Then what would be the difference between retail sale and retail transfer if
हाँ, कोई
both
डिफरेंस नहीं है.
represent?
अगेन मधुमिता, वो एनालिसिस में पकड़ में आ जाएगा. बोथ आर डायरेक्टली प्रोपोर्शनल.
So both represent the
हम्म.
same is what you are
हाँ
referring.
हाँ, सेम, लगभग सेम है. 80% दे आर कोरिलेटेड टू ईच अदर. and I have dropped retail transfer आगे के analysis में I have dropped it.
Okay.
Okay, वो analysis से पकड़ के आएगा. I know that there are few doubts, and it will rise by just seeing the data, but that's the reason now. My analysis, my Python is going to help me in that.
Okay.
Okay, so I have dropped that feature. Why I will show you. Okay, all right. So,
So for now, we are considering all the three columns as currency, right?
currency. That's what
Okay.
we are considering. Because no more details are available. We have done a rigorous analysis of this particular features.
Yeah, yeah.
Okay, so
Okay.
accordingly, that's what we can see. Okay,
Okay.
so now I checked there are no duplicates present, no null values are present, information I have printed. Okay, we are having some integer column, we are having some object column, float column, that's what we are having. Description also I have printed, okay, just for the numerical values, fine. Number of unique values if we check. So these are the number of unique values in each and every column. That's a common procedure of coding which I do follow in each and every project. Okay. Then there is one null value in retail, so I filled with the median. I don't have any issue with that. Either mean, either median, you can do that. And supplier, I am having a few null values like 33. I filled with unknown. Still here also I don't have any issue related to fill with unknown. Okay, mode भी नहीं कर सकते ना. We can't do the mode because we don't know who is the supplier for that. Okay, so unknown. And then here are my categorization like object type, numerical type, okay, categorical, non-categorical, discrete, continuous, all kind of features I separated. Yesterday only I told in my project number 1 also this code is present. So this is I classify. That's a common approach. I know that there are many people who are very good already in this particular field. They are working in this particular field. Um, this is a common approach which I do follow because I should be knowing about what kind of data type I am having. Am I right or not? Any suggestion? Yes. There are some people who are good in this particular field. Am I right or not? I should know the data type and I should do the analysis according to the data type or not. Yes.
Surely.
Okay.
Otherwise, it will give the wrong results.
So I first find out that what are discrete, what are continuous, what are categorical, what are not non-categorical features present in my data, and accordingly I do a univariate and bivariate analysis. In univariate analysis, yes, for categorical and discrete, I do make first I print the unique value counts for the values which are present in it, and then I do make count plot. This is the count plot. That means counting each and every value present in these features, annotating them in the count plot. Along with that, I do make the pie plot. So if you are new to it, those people who are learning, they just remember classify your data into different types. And for every type, you have to do the analysis. This is the visualization we are doing right now. For univariate analysis, काउंटर प्लॉट एंड पाई प्लॉट रिलेटेड टू डिस्क्रीट एंड कैटेगरिकल फिक्स है ये, ठीक है. एंड देन ये भी डिस्क्रीट का हो गया. दिस इज फॉर डिस्क्रीट. ओके, अगेन काउंट प्लॉट एंड पाई प्लॉट फॉर द डिस्क्रीट. Okay, I can check the distribution. I do have 37% for 7 month. Month number 7, 37%. More entries are there. And very less entries for month number 9. Okay, this is what I can get the insights on the pie plot. Then for continuous features, I do make histogram to check the distribution and under frequency intervals. Okay, so histoplot, distplot, that's what I make. Along with the box plot too, to check the outliers, and there are many outliers present in the data. That's what you are seeing. In retail sales also I do have outliers. Retail transfer also I am having the outliers. And warehouse sales also I am having outliers. Okay, however, I haven't removed the outliers from this data. I haven't, because you know what kind of project we are doing. Retail. Okay, retail. That means it is related to somehow what finance, transactions, payment, money. Okay, so and we also discuss about the features. All right. So in this particular case, we can we have to be strong enough to understand that how we can delete the outliers from the data. What decision you are going to take to delete the outliers from the data? Okay, that can be risky also, that can be effective also, depends. However, I'm not going to consider anything at the moment. Okay, I just see that there are outliers present in the data. Okay, fine. I made box and plot also, box plot also, Boolean plot also, all these plots I made. Okay, Boolean and Boxen are optional. Box plots are enough to show the outliers. ये extra है. And then I made bivariate analysis. Bivariate means continuous versus continuous. So for continuous versus continuous, we can make scatter plot, line plot to show or to identify how one feature is related to another feature. And one question which came to me that, sir, you are talking about retail transfer and retail sales. You can see this is a scatter plot between retail transfer and retail sales, and you can see a straight line. So from here only it is clear that retail sales and retail transfers are directly proportional to each other, and there might be like 80% or more than 80% correlation between them. So definitely for modeling purpose I need to drop one of them, and if my target is retail sales, I'm going to drop retail transfer definitely. So one question asked to me, sir, either they are same or so, according to the values they are looking same. So that is the reason I made scatter plot, to find the relationship between the features. Okay, so retail transfer, retail sales, and warehouse sales and retail sales somewhat related, but not that much. Okay, then wholesales and retail transfers somewhat related, not much. Okay, not like this line as we are getting between these two. Okay, and then I made discrete versus continuous bar plot. Okay, so you can make discrete versus continuous bar plot to show the average values. Okay, to show the average values. Okay, like this. Here. That means for retail sales, month number one, 6.20 is the average for month one. For month one, the average value of retail sales is 6.20. 6.03 for month 3, 8.45 for month 7, and 4.40 for month 9. Okay, either you can have an average, either you can have sum. Okay, here average is shown. Okay, so bar plot. Similarly, discrete versus continuous bar, categorical versus continuous also bar. That's what you can do. Also, not only bar, you can make a box plot also, you can make wall in plot also. They are also feasible. Box plot, box in plot, wall in plot are also feasible between these. Discrete versus continuous, box. Discrete versus continuous, box and wall in, all are feasible. Okay, yes, Subhashish. You can ask the question.
Sir, one doubt was there. But when you say in
Yes,
general
any doubt? Yes, your voice is very low.
1 minute, sir, 1 minute.
Okay, so all these plots now you can make.
Is it fine now, sir?
Hmm.
Yeah, sir. One thing that means suppose they are either to want to check the correlation between one categorical and one continuous value.
What? Okay.
Then
Huh?
suppose there is two values. That means one is categorical, one is continuous.
Now, categorical and continuous. So categorical will be on x-axis, continuous will be on y-axis.
Okay. Okay. Anything might be fine.
Sir.
And how can we check the correlation between them? That means yes,
Uh,
correlation.
actually, we are showing. Okay, actually, we are showing the average values for a particular categorical or a discrete or a continuous value. We are taking the average of all the continuous value for that particular categorical. Okay, that's what we are doing.
Okay. Okay. Actually, my question is the general question.
General
Suppose
question.
this
What is the
fine,
correlation? Okay, fine. If you want to
Yeah.
find the
No, no.
correlation also, okay.
No,
So,
correlation is fine. The context is we have categorical and one is continuous value. So, what will be our approach?
what will be our approach? See, one kind of approach which I have showing you right now, this kind of bar plot, box plot, Voxen, all these plots, they are trying to show the relationship only. How a categorical value is been either in a average format or either in some format, they are related. Okay, what will be the average or a sum for this particular categorical value? Entire continuous. Okay, that's what I'm taking. And another mean, you can convert categorical into numerical annotations. For example, we do say that if I'm having categorical male, female, something like that, I can make it as 0 or 1. And once they are converted into numerics, you can include them in correlation plot also. That's not an issue. You can include them in correlation. Okay, that is also been one of the thing you can include in the correlation. However, I do consider only continuous in the correlation. I ignore this categorical or discrete value in the correlation, but you can. If you are asking about how they are correlated, how to find the relationship between them. Okay, so if I put discrete value on x-axis, I put continuous value on y-axis, I will only get 1 point. Okay, let me show you. Let me show you here. If you would say, what is the way, what is the approach? So if I draw here like this is continuous, this is continuous, this is continuous. A, B, and C. I am having all, sorry, this is categorical, categorical, categorical. All these are continuous values. So for a categorical value, I should be having only 1 point. What that point could be? What that point could be? Right now I am saying you that that will be the average of all the values for that particular category. It can be some also, that's not mandatory. It can be some also. For B also I do have 1 point, for C also I do have the 1 point. So for category we do make like average, sum, minimum, maximum, all these we do take. And you very well know there are terms called pivot table. Okay, we do consider the pivot table. If you know about this thing, pivot table, like cross tabulation, all these are present in the pandas. Okay, where we do try to find the relationship. We try to make a table how these values, because continuous are the values, and these are the categories, categorical. Okay, so how these values, either in a sum format, either in average format, they are present. Now, anything more you want to say?
No, it is fine.
One more thing, as I already told, you can convert categorical into numerics. You have a chance, and once they are converted into numerics, you can make correlation also. This is also possible. But what is the sense now? Again, there is a question. What is the sense? Categorical value तो एक ही होगी ना भाई. कैटेगरिकल तो एक ही होगा ना, ए ही होगा ना यार. लेकिन कंटिन्यूस आई डू हैव मेनी थिंग्स. तो मैं ए का कंटिन्यूस के साथ क्या करूं? व्हाट शुड आई डू विद द कंटिन्यूस? ए का भाई या तो तू एवरेज निकाल ले या सम निकाल ले, या मिन कर दे या मैक्स कर दे, और क्या करेगा बताओ? व्हाट इज पॉसिबल? तो दिस इज हाउ वी डू रिलेट. All right, good discussion, good question. Fine. So here I found the correlation. Retail sales, retail transfer, and warehouse sales. Nothing more than that. I haven't included कि मैं categorical को convert कर सकता था. I can. And मैं उसको यहाँ पर ला सकता था. I can. Relationship भी I can identify कर सकता हूँ. Okay, आ जाएगा इस table में. That will be present. But नहीं कर. I am just strict towards the correlation for this continuous features. Okay, and I found from here only that retail transfers and retail sales are 84% correlated. वो तो we are able to see in the scatter plot only. 84% correlation. Fine. Okay, that means highly correlation is shown between these two. क्या करें अब? तो अच्छा, just a second. 3D plot also I made. These are the 3D plots. In 3D plot, I considered on x-axis retail sales, y-axis retail transfer, z-axis warehouse sale. Okay, x, y, z, and I considered item. Okay, so this is my 3D plot for them. You can, okay, once you move your cursor, because I made with respect to Plotly, so once you move your cursor, it will let you know. For example, item type beer, retail sales is 628, retail transfer is 586, and warehouse sales is 10.16788k. Something such values are mentioned here. Okay, and this is like 0 minus 3999. Okay, so you can move your cursor and it will give you the value. Okay, so 3D plot. After 3D plot, I made a pivot table, and that question sir asked, okay, that how you are going to relate. So retail sales is a value actually, continuous. Year and month, these are discrete in nature. These are discrete in nature. Item type is categorical in nature. Okay, so the question is how you can relate retail sales and item type. What I can do? This is the table I can make. Okay, so these are the items. Let me take on the column side, and these are the continuous values which I took. The aggregate function I took here is the sum. That means for year 2020, for month 1, what is the sum of the beer? Means what are the entries of values present in the retail sales column? No, those sum for the beer. Either I can take sum, either I can take average, either I can take max, either I can take min. So this is a relationship I can form. So pivot table for this. Then for retail transfer also I made a pivot table. Then for warehouse sales also I made a pivot table. Okay, so pivot table is very much important in pandas, very much important. I request everyone, if you are having discrete categorical data along with the continuous, it is mandatory for you to make a pivot table at least. And he asked a good question, how to show the relationship. This is a way, you can show that, okay, this much, this is the categories, and these are the max and min values for them. So these are good insights which you can put. If someone asks you, what is the average sale for beer in month 1, you can say, sir, for month 1 the average sale for the beer is corresponding to warehouse, it is 231,515, or sum of the sales, total sum of the sales is this thing. You can answer. So pivot table is very much important. Okay, fine. So I made the pivot table, separate pivot tables for all, and later on I can merge the pivot tables also. Retail sales and warehouse I took in one only. Here you can see, in one only I took retail sales and warehouse sales. एक ही में ले लिया, अलग अलग भी प्रिंट करवाया है. I did print it separately, but in one also I considered. You can insert one value also, that is revenue. ये वाला कौन सा था, रिटेल ट्रांसफर. दिस ऑल्सो यू कैन इंक्लूड. तो तीनों छप जाएगा फिर. ऑल 3 विल कम, वन साइड बाई साइड सब आ जाएगा. एंटायर कंपैरेटिव एनालिसिस हो जाएगा. यू कैन डू दैट. तो ये सब करने के बाद, आफ्टर डूइंग दिस थिंग, I already know about the correlation. I already printed the correlation above. Then I took a threshold of 75% and I found the correlation between the features. This is the same code which I have used in energy. Okay, this is the same code I used in energy. See, my format of coding, na, if you check the codes which I do share on the LinkedIn, if you do check what I do here, मेरा ये अप्रोच ही ऐसा है. मैं तय करके रखा हूं कि मुझे एनालिटिक्स करना है, इनसाइट्स ड्रॉ करना है, तो व्हाट विल बी द स्टेप्स, एक के बाद एक क्या आना चाहिए. ठीक है, इट इज डेटा पर्सपेक्टिव, बट आई ऑल्सो नो अप्रोच क्या होनी चाहिए. आप एक बार अप्रोच में क्लियर हो ना, इफ यू आर क्लियर इन द अप्रोच, देन यू कैन इट विल बी इजियर फॉर यू. एंड आई एम अवेलेबल विद सो मेनी कोड्स. It will not take much time for me to create any kind of project. All are available. This entire documentation, this code is available. Just copy the code from here and then put it here and find it. Okay, fine. तो ये हो गया. ये correlation निकाला between each and every feature. Threshold 75 है, तो correlated features में retail sales and retail transfers are there. I will drop retail transfer because I can take retail sales on my target axis. Transfer को निपटा दो. So these are my left out columns. Okay, these are left out columns. These are the number of unique values present in the columns. Okay. So what I considered is, let's make df1. Don't take df, don't work with the df, work with df1. df को safe रखता हूं मैं. ओके, सो df1, मेक अ न्यू डेटा फ्रेम df1. कभी भी डायरेक्ट डेटा फ्रेम पे काम मत करना. एक और सजेशन, इफ यू आर एक्सपेरिमेंटिंग, डोंट डू डायरेक्टली, मेक अ कॉपी. So I created new data frame df1, that is like df only. Okay, and then what I did, I took all these. I need to, first my idea is to apply the regression. First my idea is to apply the regression. Now again a question which I asked to myself, sir, you are available with year, month, item ID, item name, item description. These all you are available with. Then you are having retail sales and warehouse sales. One column you dropped. Are they enough to give you prediction for retail sales? Are they enough to give the prediction for retail sales? उसमें भी item description का क्या करूं मैं? What should I do with the item description? What should I do? Item ID का क्या करूं मैं? ID is just an identifier. What should I do with that? Neither item ID, neither item description. Am I doing NLP project? No, I'm not doing a natural language processing project. So item description will help me write the moment for something. What is my target? Retail sales. तो सेल्स का डिस्क्रिप्शन से क्या मतलब? डिस्क्रिप्शन, हाँ, आइटम इज इनफ फॉर मी. इफ आई एम हैविंग आइटम, I can talk about the sale of it. हाँ, क्वांटिटी नहीं है मेरे पास अभी. द इशू इज आई डोंट हैव द क्वांटिटी, आई डोंट हैव द प्राइस. ये दोनों नहीं है मेरे पास. क्या करूं मैं? What should I do? So in the next case now, what I decided is, भाई मैंने तो रिटेल सेल्स और वेयर हाउस सेल्स, अभी रुकिए जरा मैं बता रहा हूं. What I did, I took only the features year, month, supplier, item type, and warehouse. I didn't considered item code and item description. So the df1 which I made comprises of year, month, supplier. I should know the supplier. Item type. Okay, he is the supplier. This is the item which he supplied. This is the sales. This is the warehouse sales. Either I can give in the prediction, either this or either this. There are many options to me. Sir, time series में लेकिन एक लफड़ा हो रहा है. There is one issue with the time series. तो time दिया है आपको, that is separate, year and the month. Either you merge these two, merge year and the month. Sir, day कहाँ से लाओगे? From where you will bring the day? We don't have any day. That means we are having the data of the entire record for month 1. We don't have the day wise data. Again, there is a challenge. क्या करोगे फिर? What you are going to do with that? Fine. So, okay, I took all tension side. I just took only these features. Okay, and then because I need to apply linear regression, one more thing. Sir, feature engineering, sir. Are these features enough? You have already reduced further more features. Now you are only available with year, month, supplier, item. That's it. And you're talking about the retail price calculation, the warehouse. 1, 2, 3, 4, 5. Only 5 features you are available with. You're talking about the retail price prediction. And in that also, year and month are discrete. Supplier and item are categorical. Not only small categories. Item, both are big categories. Okay, so what you are going to do? One hot encoding for them. यू हैव टू डू वन हॉट एनकोडिंग, ये तो करना ही पड़ेगा ना, वन हॉट एनकोड करना पड़ेगा. Okay, so I need to make columns for each and every supplier. I need to make column for each and every product. I need to do one hot encoding. मेरा डेटा अब लेंदी हो जाएगा, इससे लेंदी हो जाएगा. फिर एक इशू और आएगा, स्पार्स भी होगा ये. स्पार्स मीन्स यू विल बी हैविंग सो मेनी जीरोस प्रेजेंट इन द डेटा. ये भी एक इशू होगा. वन हॉट एनकोडिंग में ये लफड़ा है. One hot encoding, the major issue is you do create a sparse data. And
Dummy data.
हाँ, डमीज है वो, वही एक ही बात, डमीज है. तो डमी क्रिएट ये हो गया, वन हॉट एनकोडिंग हो गया. सम डोंट प्रिफर डमी ना, वो प्रिफर नहीं करते. ओके, तो क्या क्या करेंगे, ये सब प्लान आता है दिमाग में अपने आप. द पर्सन हु डू वर्क ऑल दिस थिंग्स ना, आप यू गाइज आर been knowing. So what come in my mind, see, this project session is based upon the discussions. It's not like that I'm going to teach you कि ये कोड है, ये कोड है, ये नहीं है. कोड तो दे दूंगा, that I will give you. That's not the issue. Coding also, you know, we are focusing upon the concepts, we are focusing upon the problems, the areas where we want to improve ourselves. इट्स अ जॉइंट एफर्ट, ऑल सबका है. मेरा, मैं एक मीडियम हूं बस यहाँ. ओके, तो भाई क्या हुआ, व्हाट आई डिड. अच्छा, एक वन मोर कंसर्न केम इनटू माय माइंड. ओके, यू आर लुकिंग फॉरवर्ड फॉर दिस थिंग, रिटेल सेल्स प्रिडिक्शन. एंड व्हाट वी चेक्ड, देयर आर जीरो एंड नेगेटिव वैल्यूज. एंड इफ यू ट्राई टू अप्लाई लीनियर रिग्रेशन, भाई ये तो फेल हो जाएगा. दिस विल फेल. Why? Because you very well know that I need to apply transformation. I need to apply the transformation. लगानी पड़ेगा ना मुझे transformation, and that will be the log transformation. Either I will take the square root. But square root I don't prefer, I go with the log. And log cannot take zero or negative value inside it. लफड़ा. क्योंकि continuous it is mandatory. ध्यान रखना, नहीं तो लीनियर का आंसर अच्छा नहीं आएगा. यू हैव टू ट्रांसफॉर्म योर डेटा. दिस इज द रिक्वायरमेंट ऑफ द एल्गोरिथम. तो लॉग ट्रांसफॉर्मेशन यू हैव टू अप्लाई. एंड माई कंटिन्यूस फीचर्स आर जीरो एंड नेगेटिव, फ्यू वैल्यूज आर देयर. ओके, सो व्हाट आई डिड in that particular case, what I did, see here. Okay, I find the minimum value. The minimum value for them are -3,999. I found the minimum value. Then what I do? I found a constant. That means take the absolute of the minimum value, add 1 to it. If the minimum is less than or equal to 0, okay, if the minimum is less than or equal to 0, then perform this activity. Okay, so that's what I did. And the constant term up to be 4,000. So if I am having -3,999, answer will be 4,000. I just changed it. Yeah, now this will be something, sir. Obligation तो नहीं है. Isn't it an obligation? Isn't it an obligation? Sir, negative sales means negative revenue, means negative money. That means loss. That means loss. कोई इशू नहीं भाई, मैं मेरे मॉडल को जिस तरीके से ट्रेन कर रहा हूँ, the way I am training my model. Okay, if I get certain amount of data, like this data only, negative also, I will follow the same approach to that. Negative तो पुट कर ही नहीं सकता ना, तो नहीं तो I can't apply linear regression. If I do apply, I can, but I will get MSC, mean square error, very high, बहुत बड़ा आएगा वो. तो ये अप्रोच लगाई मैंने यहाँ पर ट्रांसफॉर्मेशन की नेगेटिव के साथ. आइदर यू कैन डू वन थिंग, सर नेगेटिव को हटाई दो, फिर रिमूव नेगेटिव, हटा दो नेगेटिव एंड जीरो वैल्यूज रिमूव. ये लेकिन डेटा लॉस होगा. डेटा लॉस मेरे को करना नहीं. आई डोंट वांट टू डू द डेटा लॉस. Okay, so there are many things which we have to consider, which we have to take care of while doing the analysis. Yes. Okay. So what I did is, okay, converted that into constant. Then I took the log. Then I took the log. Okay. So constant is 4,000. And whenever the retail sales is negative, okay, whenever the retail sales is negative or whatever be the negative values, it will turn up into positive value. It will turn into positive value. So log will be safe. So in retail sales and warehouse sales, I took the log by keeping myself safe. Okay, now finally, this is my target. These are my training features. These two are categorical. These three are numerical. Year, month, log, these are numerical. Okay, so what I did, I created column transformer. See, I can solve it individually also. You can convert that I have shown in my previous project. So I think let's do something new. Okay, so this is data pre-processing. Okay, but data pre-processing in one shot itself, in one go itself. That means I will take the numerical feature. I will not go. I will not do anything with it. That means pass. However, if I take categorical feature, I will perform one hot encoding of it. So either you can do separately, either you can use this technique, column transformer. That is data pre-processing in one go itself. Okay, so both these I am going to supply it to the pre-processing. Numerical I pass, categorical I will one hot encode. Okay, description I have mentioned because yesterday I came with a doubt, sir. For few codes, kindly include the description. Okay, so that's what I did. Yes, Madhu.
Sir,
Ah,
so the first question would be regarding this label encoding.
hmm,
So we had spoke about this one hot encoding would increase
hmm,
the number of features,
hmm,
and
hmm,
we have this concept of curse of dimensionality, right?
Curse or
So
dimensionality.
when,
Yes.
yes. So why are we again taking up this one hot encoding? And as far as I remember, we have specific conditions to perform this label encoding.
Hmm.
Depends upon the
This is one
data
hot
set.
actually. Okay, label encoding, one hot encoding, both are different. Let me again
Dif-
different. So as
I
you,
mean, on a whole, the encoding technique, I would say.
hmm, hmm,
So we are performing one hot encoding, and
hmm.
I mean, can you be very specific at what, in which type of data can I use one hot? And so we have so many, right? Count encoding and whatever it is.
Hmm.
So on which kind of data is needed to perform this one hot encoding? That
Okay.
is first question.
Hmm.
Okay, you can answer this. I'll ask the next one.
Okay, fine. In which we are going to use the label encoding, or in which we are going to do the encode. Okay, label encoding or one hot encoding. Label, as if you check the data, that's not like in a order. Okay, we are having items, so items can be in like beer we are having, alcohol we are having, non-alcohol we are having. They are not like an order. So label encoding is totally failed. That's one thing. Only
Hmm.
the ways we have to do the one hot encode. For one hot encoder we have to make the separate features. That means separate column for each and every. That means for beer also separate column, alcohol also separate column, non-alcohol we have to make a separate column. Okay, now what is the reason that we are doing this particular thing in our project? See, we are doing a project related to the retail. Retail is
Hmm.
related to selling. What we are selling, that is the question. What you are selling? If I
The,
do, if I do have only year and a month, if I remove who is the supplier, who is the item they have supplied, what I'm left with? What I'm left with?
just with this year, month, and warehouse sales,
हाँ,
probably.
तो इससे इससे मुझे what I'm going to achieve from that. इससे बेटर तो ये होता, तो आई विल नॉट अप्लाई दिस रिग्रेशन, मैं तो टाइम सीरीज लगाता फिर तो. दैट इज अ बेटर
Hmm.
ऑप्शन.
Hmm.
Okay, then time series is a better option. Why you are applying this regression technique?
Hmm.
So the point is, again, curse और dimensionality तो है, definitely I agree with you, there is curse or dimensionality, because the one hot encoding will make so many columns, वो तो है, sparse भी है, ये दोनों issues हैं, होंगे definitely, but ऐसा है, I need to know about the item sold, and I need to know about the supplier also, who is selling the items. Okay, ये मुझे पता होना चाहिए. Same thing. Now you ask, in what kind of problems? जैसे house price prediction है, for example. In house price prediction में, if you do have a locality or area, and this is also important that we should know in which locality or area we are going to purchase the house. For example, there are hundreds of localities. There are hundreds of areas. What you are going to do? One hot encoding. Okay, I want to take house in a locality A, and the price here is this thing. I need to take a house in locality B. The price is this thing. So if any of the concept came, like one hot encoding came, label encoding came, obviously they need to turn up the values, the categorical values into numerics. And once it is converted to numerics, they are going to be usable. Because again, it's a data, na? It's an information to me. I can't put categorical value in a model for the training. So I need to convert it into some numerics. Okay, I need to convert it into some numerical format. That is the only way. अब इससे कर्सर डायमेंशनलिटी हो रहा है, स्पार्स हो रहा है, ठीक है, लेकिन कर्सर डायमेंशनलिटी में भी क्या है भाई, आप मुझे ओवरफिटिंग की बात बोलोगे ना, टॉक में अबाउट ओवरफिटिंग ना, ये कर्सर डायमेंशनलिटी से क्या रिस्पॉन्सिबल है? इफ यू आर हैविंग सो मेनी फीचर्स, द पॉइंट इज आप मुझे क्वेश्चन कर दोगे दे मे बी कोरिलेटेड है तो ओवरफिटिंग हो गई, यही तो होगा. Or anything in your mind, or you can put up the second question also.
Yeah. So yeah, and right now you're mentioning like we had these many challenges. I am convinced with the first point you said. So if your data is not ordinal, that's what you're trying to say, right? Like it is not in order, whatever it is. So in that case, one hot encoding can be preferred. So if your data is ordinal, then you
Label encoding.
then you suggest to prefer label encoding. That would be the conclusion, right, for this particular question. Okay. So what any other idea about other encoding techniques? I would say like we have I remember frequency encoding, probably, yeah. Frequency doesn't fit here. Count encoding, we have other encoding techniques as well, right? Any inputs on that?
Any inputs on them? Well, to be very clear, I haven't used any other encoding so far.
Okay.
I haven't used such kind of encodings in my so far projects I did. All right. So in case if they come up in front of me that these are the preferred ones for a particular problem statement, so definitely I can comment something on it. Right now I can't comment anything on that.
Okay, sure. Okay, the second question would be regarding this negative values, where you were mentioning that linear regression wouldn't be that suitable when we have the negative values, and we had applied the logarithm. So maybe can you explain in very specific, like I couldn't get that, like how this logarithm value is trying
logarithm? Okay, fine.
Yeah.
See, Madhumita, actually क्या होता है? As I told in my project number 1 also, here I am also putting the remark that every model do have requirements. We can't put the data directly into that particular model. Then that's the reason you do the entire pre-processing and everything you do. Okay, everything you do. So linear regression model, इसकी requirement है कि जो continuous features हैं, the continuous features, they should be like normally distributed. वो उसका assumption है. That is the assumption. that it should be normally distributed. Mandatory nahi hai that we are going to make it normal only, but if it is not normally distributed, now because we need to follow up the assumption, तो उसने बोला है, recommend करा है, according to the linear regression assumption, they recommended that okay, you have to apply transformation, and in each and every algorithm we do apply the transformation. For example, in support vector classifier regression, there also we apply the transformation like standard scalar. Standard scalar. In deep learning also we apply the transformation, that is standard scalar. Deep learning also standard scalar, because they do expect the data of that particular type so that they can analyze it in a better way. So linear
So
regression.
the standardization is to have values in a specific range, correct?
In a specific range. The formula is x minus mu upon sigma.
Okay.
This is standard
So-
scalar formula.
Okay.
And here we require normal. After log, if doesn't comes normal, but it's not like it will come up and beat us. No. But we gave a chance to that particular continuous distribution, क्योंकि continuous में reference plot ही normal distribution है. If you talk about the entire stats, reference plot ही continuous distribution का normal है. Okay, and if I do say normal, कई बार मैं formula भी लिखता हूँ. The formula for normal is 1 upon square root 2 pi sigma e की power minus x minus nu का whole square upon 2 sigma square. This is the formula for normal distribution.
Okay.
Okay, and this is how normal looks. You know it. This is how normal
Correct.
looks.
Yes.
Okay, where mean median mode
Yeah.
all are equal. तो वो कह रहा है कि भाई आपको रिग्रेशन लगानी है. रिग्रेशन लगानी है, if you want to apply the regression, भाई मीन मीडियन मोड इक्वल होना चाहिए. भाई तुम if you are going to put a data which is skewed in nature or something like that, तो भाई मेरा regression analysis will fail. समझे आप मेरी बात को? I will get more error. MSc
Okay, so we are-
MSc will rise. तो सबका टेक्निकल आंसर है, टेक्निकल. तभी वो कह रहा है कि यार ऐसा आपका ओरिएंटेशन इफ इट इज गुड, द डिस्ट्रीब्यूशन इज गुड, तो माय रिग्रेशन एनालिसिस विल बी गुड.
without sugar.
Okay.
ऑलराइट, सो दैट इज व्हाई आई टुक द लॉग.
Okay. But as far as I remember, whatever transformations we perform, it would be on the entire data set, right? So here we are trying to perform the normalization.
No, not on entire. Again one thing, continuous features. डिस्क्रीट पे आप डिस्क्रीट पे लॉग लगाने का कोई सेंस नहीं है. देखिए, अब आपने जो पढ़ा है वो अलग बात. अब मैं प्रैक्टिकल पॉइंट ऑफ व्यू पर ही आ रहा हूँ, क्योंकि नॉर्मल डिस्क्रीट का थोड़ी ना होता. Normal distribution is not for the discrete. Normal distribution will be for the continuous.
Continuous. Okay.
Okay, so if you apply log on discrete also, what it will give? What it will give? हाँ, standard scalar आप लगा सकते हो
हाँ.
और entire numerical. अब आप समझ गए, आपने शायद उस चीज का बोल दिया. Standard scalar you can apply. In SVM you can apply standard scalar to all. लगा सकते हो.
Okay.
लेकिन उसमें
But
भी
not
मैंने
for linear
हाँ,
regression.
not for linear regression में नहीं करना है काम. Okay.
Okay.
You can scale month also, you can scale year also in standard scalar.
Okay.
कर सकते हो, लेकिन यहाँ पर मैंने उसको भी स्किप करा. मुझे ठीक नहीं लगा. कुछ चीज़ें मैं देयर आर समथिंग ना, सेल्फ एनालिसिस भी होता है. ठीक है, देयर आर मेनी. ओके, बहुत सारी बातें हैं. ओके, बट सेल्फ एनालिसिस इज ऑल्सो वन ऑफ द थिंग. आप काम करते आ रहे हो ना, यू आर ऑल्सो डूइंग अ लॉट ऑफ एक्सपेरिमेंटेशन, एवरीथिंग. देयर इज ऑल्सो सेल्फ जजमेंटल.
Okay.
ओके फाइन. तो आप शायद उसका बोल रहे थे, स्टैंडर्ड स्केलर का. सब पे लगता है वो.
Okay.
ठीक है, फाइन, ऑलराइट.
Okay.
ओके, अदनान. यस अदनान.
Hi, sir. Yeah, so I have a question regarding this. So, like, if we are doing one label, one hot encoding on our data set, so it will lead to overfitting. So, if like we have any statistical methods we can apply to reduce that overfitting after doing that one hot encoding.
Okay, again,
So,
okay, what is the scope? What we can do after doing the one hot encoding? Any statistical method, or are we, because we are having so many features created after the one hot encoding, because there are many suppliers, there are many items available, There are wide range of features will be available now.
Yeah.
Okay, so are we considering any specific features only out of them after doing this thing also?
So we need to look for correlation or something
आगे
else like
आपका
that.
कोरिलेशन देखोगे वो बहुत बड़ा बनेगा अदनान.
Probably
Acha.
we can consider this feature reduction
Feature
techniques like
reduction technique.
PCA.
Like principal component analysis, like
See
something like
again,
that.
PCA एक unsupervised पे चला जाता है. If you talk about the PCA will move towards unsupervised, क्योंकि PCA जो है that is for जो distance based algorithms होती है ना, their PCA is applicable. Unsupervised की algorithms होती है. And in supervised, support vector machine is something where you are going to talk about the distance based.
Okay.
Only the thing is correlation identification करो drop कर दो.
Mm-hmm.
अभी तो मुझे
Okay.
that's what coming in my mind.
Okay, fine. Thank you.
But in that case, sir, like we'll be creating separate columns for each of the
Now
different
not
item
separate
types.
columns, huh? Yes. We
Correct.
already creating separate columns, huh?
So in that case, if you are trying to pick up the correlation, the whatever the columns
बहुत ज़्यादा हो
generated as a
जाएंगे.
new
Many,
one, it
many.
would be highly correlated, right?
Hmm.
And there is a chance that we are dropping them as well.
Dropping them. So that means we are losing certain product type also. We might be losing some seller also. If they are correlated. लेकिन वो correlation में भी क्या 0-1 है. वन हॉट में कोरिलेशन इफ ट्राइड 0-1 के तो कोरिलेशन निकालना पड़ेगा. दैट्स व्हाट यू हैव टू डू. क्योंकि वन हॉट एनकोडिंग 0-1 में ही हुआ है. ट्रू फॉल्स में हुआ है. व्हाटएवर डमी बोलते हो तो.
No, my question is like if true, false, whatever two columns you're trying to mention, even we have a chances that they both are getting highly correlated. And if we just go basis on correlation, maybe we have to drop either one of them as well, right?
Yes.
So then what's the point of performing this one hot encoding? I mean, if you're trying to drop the column after performing the correlation, then it doesn't make sense, right?
That's why I haven't done. No? That's why I haven't done.
So the dropping the features after performing one hot encoding doesn't happen, right?
Doesn't happen.
That's what I would-
Doesn't happen.
yeah.
Normally it doesn't happens. And but the question was very nice. That's the question. Curse or dimensionality, overfitting. So what do we do? See how much scope we are having related to that. So we are not dropping. Okay. So let it be the
Or
product.
probably, is there any scope to perform this L1 L2 regularization?
Regularization. No, there are regulation techniques. Yes. So either after
For
using
linear.
see if we have issues with the overfitting related to the linear, we can use lasso and rich. If you have more issue, then you can use elastic net. They are the regulation techniques. Okay, we can apply lasso also, ridge also, and we can apply
Yeah.
elastic net also. That is a combination of L1 and L2 both. You can
Yes.
try with that.
Maybe we can try in the same.
यस तो L1 अपने आप ही निपटा देगा ना. आपको जरूरत ही नहीं है ड्रॉप करने की. इट्स अ गुड थिंग यू आस्क फॉर रेगुलराइजेशन. L1 तो खुद ही डायमेंशनलिटी रिडक्शन है. वो फीचर सिलेक्शन एक्चुअली. L1 इज अ फीचर सिलेक्शन. लेस सो. ओके सो इट वो सेल्फ ही ड्रॉप कर देगा जो और विच आर रिस्पॉन्सिबल फॉर ओवरफिटिंग. Okay, so that's a good thing came regression term. So I use linear regression here and rest इस कोड में आप अपडेट करिएगा. Okay, kindly do update the code and use lasso also, ridge also. L1 and L2 regression techniques. So far when I have used my linear regression, the error is very very less. 2.29 into 10 की power -5 and R2 is 0.29. The error is very less. R2 means 29 or 30% of the points are captured by the actual. This is how the plot is coming. This is actual and green are the predicted. Okay. So linear regression show good response. However, because that's a good point. Let me mention here only. Okay, you have to apply L1 and L2 regularization techniques. If not, because I will be giving you the updated code, I will apply. आप नहीं करोगे तो मैं तो करके दूंगा अपडेटेड में. ओके, दैट्स व्हाट यू हैव टू डू. फाइन, मुझे अब याद रहेगा, मैं कमेंट कर दिया, मैं अपने अपडेटेड कोड में इंक्लूड करूंगा. एंड देन आफ्टर this I use SVR, so I included standard scaler. Decision tree, random forest, XGBoost also. I included all, बाकी बच्चे वो all I included. And again, this is my DF1. This is my X and Y. I applied column transfer, that means I perform one hot encoding for, again, categorical. And scaling for this one, warehouse sales. हालांकि जितने भी न्यूमेरिकल है सबको ठोको. You could have like year and month also here. Year and month can also be put here in the scaling. Now let me put a comment. ये तो मैं I did from my side that I haven't put year and the month, but you can kindly put year and month in scaling. That is also I am writing. Here also you can put scaling में. वो तो सारे फीचर्स होते हैं स्केलिंग न्यूमेरिकल वाले. ओके, आई जस्ट टू बी वेरी स्पेसिफिक कंटिन्यूस के साथ. ये ईयर और मंथ को आई कीप्ट एज इट इज. क्यों? क्योंकि ईयर ओनली 2020 था, इसका कुछ करा नहीं. मंथ भी 4 ही थे, 1, 3, 7 and 9. ओके, सो कोई ज्यादा मुझे नहीं लगा कि इंपैक्ट होगा कुछ, तो ओनली वेयर हाउस आई गिव. And then I applied all these. अच्छा, decision tree, random forest and boosting, ये नहीं, they don't expect scaling data. One more thing I want to clear. इनका requirement नहीं है. Okay, now let me put a comment here. This decision tree, random forest and XGBoost, they don't require, उनके assumption में mention नहीं है ये कि they require scaled data. No. they say that भाई हमें correlated data नहीं चाहिए, correlation, because decision tree is much more prone to overfitting. Random forest is made up of decision tree, तो भाई ये overfitting तो ये भी overfitting, और boosting भी भाई decision tree से ही बनाया तो ये भी overfitting. तो अच्छा, only the thing is random forest में parallel होता है connection, XGBoost में sequential होता है. Bagging and boosting, you know about this thing. This is bagging, this is boosting. So ये algorithms can be subject to overfitting. Okay, they don't demand for scaled data, but I did scaled for support vector classifier, and I have seen in my analysis many of the times that's giving scaled to these algorithms, they improved the results. ये मेरा practical analysis है. हालांकि इनके assumptions में ये notify नहीं है, because the working culture of decision tree ये scaled नहीं मांगते, ये distance based algorithm नहीं है. Okay, the approach of splitting the data in decision tree is something different, based upon entropy, Gini score. Distance based नहीं है. SVR है तो I am applying standard scaler. But anyways, they give some good results, so I am keeping it. Okay, and here you can see the results. These are the results. Okay, so MA, mean absolute error, I calculated, and these are the R2 scores. Okay, for them. Linear regression is showing good. However, R2 score of linear regression is less than random forest and XGBoost. Okay, yes.
Sir, one small doubt here. Like, when will we consider this actual R square? We have R square and actual R square, right? So
Actual
in which
adjusted, बहुत सारे.
yeah, I'm sorry, adjusted R square.
एडजस्टेड आर स्क्वायर और आर स्क्वायर व्हेन वी आर गोइंग टू कंसिडर, एडजस्ट करना पड़ता है आर स्क्वायर को, क्यों एडजस्ट करना पड़ेगा, क्या प्रॉब्लम आएगी दिस आर स्क्वायर? व्हाट डू यू थिंक? What problem should we are facing in this r square? So we need to require an adjustment for it. क्यों करना पड़ेगा एडजस्ट? क्या हम इससे काम नहीं कर सकते?
I remember there is some issue with the some formula. If the values are, I don't remember exactly as of now, but it's because of the denominator value somewhere it is becoming.
What comes in the denominator? What comes in the denominator? R2 score. You are saying that how much percentage of the predicted are mapping with the actual. That's what I think. मतलब मेरा ऐसा मानना है, क्योंकि R2 score lies between 0 to 1. 1 means you are having 100% fitting. 0 means okay, there is no fitting. 0.5 means there is 50% fitting of the actual and the predicted points. And we may get negative score also, जो कि पूरा मॉडल फेल है फिर तो. If you get negative R2, that means entire model is failed. Okay, तो R2 is how we do capture. This कितना percentage, कितना portion of predicted actual के साथ मैप हो गया. That is the R2 score. Okay, ठीक है. अब आप बताइए किसका रेशियो, whose ratio you are talking about? Are you talking about predicted upon actual? I am having 10,000 points in predicted, 8,000 points of 10,000 points in actual, 8,000 points in predicted. We are taking the ratio of them, they got mapped. So the R2 is 0.8, 80% are mapped. Or what else you are saying? ठीक है, बताइए. Or why you are looking forward to adjust the score?
I don't remember that exactly. Maybe if you could add on it, it would be great.
Okay, ठीक है. अब वैसी प्रॉब्लम स्टेटमेंट अभी आगे आएगी तो मैं आपको ऐड करूंगा. I will add this thing. Okay, again let me put a remark here. Okay, so you told actual R2, it's not actual, it's adjusted.
Adjusted, yeah.
Okay, adjusted R2 score. ठीक है, I am putting a remark here. Alright, and you told about a ratio, R2 ratio है, ठीक है. So यदि आप मुझे बताएं what come, आपने बोला denominator numerator, आपने कुछ ऐसा बोला, तो मैं अपनी तरफ से I did told कि ऐसा कुछ ratio जो है you can consider, because R2 what I believe is how much percentage, how much fraction of the actual and the predicted points are mapping, coming on the actual line, predictions coming on the actual line. This is what you do look for. Here. Okay, here it is. Let me draw. Okay, here it is. This is your actual line. These are the predicted points. There may happen some predicted points are coming on the line, some may away, some may down, something like that is possible. Okay, so R2 score, R square depends करता है वो क्या pronounce कर रहे हो आप उसे, R2 R score. That means how much fraction of these points are coming on the actual. Okay, so आपका MSC भी हो गया and R2 भी हो गया. These two things. Error, how much away from the line. R2, how many of them coming exactly over the line, mapping. Okay, so अब रेशियो बोल रहे थे, आप समझ जाइए किस चीज़ का रेशियो होगा. And now adjusted R2. ठीक है, इसके बारे में मुझे बताना है आपको. We are already in a overdose. ठीक है, मुझे कुछ बातें और बताना है. एडजस्टेड R2 रिक्वायरमेंट के हिसाब से बताऊंगा. ठीक है, एज पर द रिक्वायरमेंट. ओके, क्योंकि अभी आपने किस पर्सपेक्टिव से पूछा मुझे ये बात समझ में नहीं आई. जस्ट फॉर जनरल पर्पस पूछा या आपने यहाँ पर कुछ ऐसी चीज़ देखी, हैव यू सीन समथिंग दैट मुझे R2 कम लग रहा है तो मुझे एडजस्ट करना पड़ेगा. आई डिडंट गेट योर पर्सपेक्टिव फॉर दैट. ठीक है, एनीवेज चलो आप एक बार और रिवाइज.
No, I am asking on a very general point.
तभी मैंने बोला when it comes to me again for some point of view मैं आपको बताऊंगा.
Okay.
फाइन. क्योंकि एक थोड़ा सा और बात मुझे बतानी है, वो ये है कि फीचर इंजीनियरिंग ऑल्सो आई इंक्लूडेड, बिकॉज सो फार वट एवर बी द एनालिसिस आई डिड विद ओनली फ्यू फीचर्स. Okay, so I created some more features from my side. Isko I haven't used in the analysis, but just for a suggestion, I put that you can have a sales ratio. That means retail sales divided by warehouse sales. You can have a sales ratio. Okay, and you can have sales difference also. Okay, see these two you can make from your side. Okay, आप इनको बना सकते हैं and you can use in the analysis जैसे कि retail sales minus warehouse sales, that can be like ठीक है, ये एक नया बन जाएगा आपके पास, सेल्स डिफरेंस आ जाएगा. सो दिस कैन बी इंक्लूडेड इन योर एनालिसिस. सेल्स डिफरेंस कैन बी इंक्लूडेड इन योर एनालिसिस. ठीक है, फाइन, ऑलराइट. तो भाई ऐसा है कि आप ये नया कुछ फीचर बना सकते हो. आई कैन हैव रिटेल सेल्स ग्रोथ ऑल्सो एंड आई कैन हैव वेयर हाउस सेल्स ग्रोथ ऑल्सो. सो आई कैन मेक 4 फीचर्स इन फीचर इंजीनियरिंग. ठीक है, ये मैं कर सकता हूँ. हालांकि आई हैवंट यूज, बट आई एम जस्ट गिविंग अ सजेशन. यू कैन क्रिएट न्यू फीचर्स. ऑलराइट. और अभी उन्होंने पूछा सर एडजस्टेड R2 स्कोर की बात कर रहे हैं, क्योंकि हम तो R2 स्कोर को तो सीधी सीधी बात है. अभी मैंने आपसे क्या बोला कि हाउ मच वी आर मैप्ड, एक्चुअल एंड प्रेडिक्टेड, हाउ मच दे आर मैप्ड, जिसको हम एक अच्छा टर्म है, दिस अ वेरी गुड, इसको कहते हैं अपन गुडनेस ऑफ फिट. आई गेस सही बोल रहा हूं मैं मधुमिता?
Yes, sir.
है ना, इसको गुडनेस ऑफ फिट बोलते हैं या R2 को.
Okay.
ठीक है, इट्स कॉल्ड एज गुडनेस ऑफ इट. और एडजस्टेड R2 स्कोर भी यही है कि आपको जो प्रिडिक्शन करना है. ओके, बिकॉज लीनियर रिग्रेशन में प्रिडिक्शन ही आपको चाहिए आंसर. ओके, सो इफ आई नीड टू एक्सप्लेन, अच्छा यहां पर लफड़ा क्या है, वही बात आ गई ना, वेरिएंस वाली. वेरिएंस वाली. इफ आई नीड टू एक्सप्लेन द वेरिएंस ऑफ माई डेटा इन अ बेटर वे, सो आई नीड टू यूज R2 एडजस्टेड इफ आई कैन शो द प्रिडिक्शन बेटर. अब आपने पूछा, मैंने बहुत थोड़ा सा हाईलाइट करा, क्योंकि डिटेल में बात नहीं कर पाऊंगा अभी. ठीक है, वी आर जस्ट टाइम कंस्ट्रेंट के हिसाब से. ऑलराइट, अभी कभी सेपरेट रहेगा तो फिर मैं बताऊंगा, या मेरे सामने प्रोजेक्ट में ही इफ आई नीड टू यूज समवेयर आई विल टॉक.
Sure. Yeah, just now I have remembered the issue with R square is like we have when we, as you rightly mentioned, definitely it's used for variance, and then adding that the challenge over this R square is if the more features are available in the data set, even though if it is not contributing to the output, the R square value would be higher.
Higher.
So, yeah, now maybe in our perspective, we have used the one-hot encoding, and then we have increased the number of features. Okay, and maybe this could be a little bit inappropriate or inappropriate. So probably we can consider adjusted R square, because obviously we have increased the number of features.
The number of features, and there are many features, and not every feature is contributing to the model
Correct.
development. Okay,
Correct.
that's what you are saying. All right. So that's why I took the consideration that you mentioned ना adjusted also. तो मैंने consider करा, इसलिए उसको comment में भी यहाँ पर mention करा कि I will apply this thing, और updated code में इसको show कर दूंगा.
Sure.
Alright, तो वो वेरिएंस वाला मैटर है. अब क्योंकि आपके पास वन हॉट एनकोडिंग करके 0-1 वाले बहुत सारे बन गए, तो अच्छा हाई वेरिएंस. अच्छा, ये आपने वेरिएंस का भी लफड़ा क्या है. दोस फीचर्स विच आर हैविंग हाई वेरिएंस दे कंट्रीब्यूट लॉट टू द मॉडल डेवलपमेंट. ये जनरल थ्योरी है, आप सिर्फ R2 पे मत जाओ. नॉट ओनली रिलेटेड टू द R2, दिस इज अ जनरल परसेप्शन है कि जिनका वेरिएंस ज्यादा, जिनका डिस्ट्रीब्यूशन ज्यादा, उनका मॉडल डेवलपमेंट में कंट्रीब्यूशन ज्यादा. लेकिन एक परसेप्शन और भी है, ओवरफिटिंग. वेरिएंस के चक्कर में ओवरफिटिंग भी होता है, तभी तो अपन ट्रांसफॉर्मेशन करके बैठे. ठीक है, ओके, बहुत सारी बातें हैं. चलिए, अच्छा डिस्कशन रहा आज भी. ऑलराइट, अब मेरे पास नेक्स्ट है अनसुपरवाइज्ड. सो ऑन मंडे, लेट मी क्लियर यू वन थिंग. लेट मी स्टॉप द रिकॉर्डिंग.